Hello, guys. So, today we are here to solve a very interesting problem. And why it is interesting that I'm going to demonstrate in a few minutes from now. Okay, so as always, before solving this problem, it's mandatory, it's clearly very, very relevant that we go through the problem statement. And in this problem, the problem is you know uh, about string. Okay, so let's go to the problem, and this problem is about circular sentence. Okay, and a sentence is a list of words that are separated by single space with no leading or trailing spaces. So every word is separated by single space and there is no leading or trailing space. Okay, so a sentence can have you know many words, or it can have only a single word. So if the sentence is having two words, then it is like this. If it is having only one single word, then it is like this. If it is having many words, then it looks like this. Okay, so our sentence only consists of uppercase and lowercase English letters. Okay, and the sentence is circular if the last character of a word is equal to the first character of the next word, and the last character of the last word is equal to the first character of the first word. So the two things that we need to check is this. Okay, that if the sentence consists of multiple words, then last character of each word is equal to the first character of the next word. Okay, this we need to check. And then last character of the last word is equal to the first character of the first word. Okay, so at the outset only we can check this. Okay, at the beginning only we can check this. And to check this, we need to go through each words of the you know string. So now we'll think of solving this problem. And in order to solve this problem, we'll have to employ some of the logic that we are going to use here. Okay, so let's think about it. Okay, so see, one good idea that we can have is that we can split this string, split this given sentence, okay, into its constituent words. And that we can do using this sentence dot split. Okay, and there is this regex which you must be familiar. Slash s plus plus. Okay, I forgot this regex. Let me check what is the outcome of this. I want to check whether my regex is correct or not. Okay. So it seems my regex is correct. Okay, so now we will go ahead. Okay, so how many words are there in this? So before even doing this, we can put a check. Okay. And that check will be if sentence dot charat 0 is not equal to sentence dot charat sentence dot length minus 1, then return false. like this. And now what we will do that, we will go through each word. Okay, so we will start with int I is equal to 1, I less than, so int n is the length of this sen arr dot length, and we'll put this n over here. Okay, if sen arr of I minus 1 dot char@, sen arr I minus 1 dot length minus 1 is not equal to sen arr ith character dot char@, 0, return false, otherwise return true, and we'll run this. Perfect. So see, our solution is working correctly, but it's not a very efficient solution. There are many other solutions which are far more efficient than this. What to do to make our solution little more efficient? Okay, so see, we are splitting. Okay, do we really think that we need to split? We recognize that the splitting point is the space character. So instead of splitting it up and putting it in an array, why not just look for the space character and then one character behind and one character after it? Because one character behind is the last character of the previous string, previous word, and the 0th character after the space is the first character of the next word. And that's what we have to check. So this splitting is an unnecessary overhead. Okay, we need not do this. Okay, and what we need to do over here, that we can use this int n is equal to sentence dot length, like this, and then this we can remove it to n. Okay, and then this n will be as it is, and then we will put a check if sentence dot char@, of I is equal to, if it is like this. Okay, if it is like this, then what we will do, we will check the character. See, a sentence is a collection of words. That's what the description also says. A sentence is a list of words, okay, that are separated by single space with no leading or trailing spaces. So there is no leading or trailing spaces. Only in between two words of the sentence, in between two consecutive words of the sentence, there is this empty space. And since character ith index is for the space character, then sentence dot char@, I minus 1. Okay, so the first condition says that last character of a word is equal to the first character of the next word. So I minus 1 must be equal to sentence dot char@, I plus 1, and if it is not equal to, then we will return false. Okay, otherwise we'll return true. So let's see how this logic performs. See, we have removed the overhead of splitting. Okay, Now we are iterating through the characters of the string, and if at any index the this character at that index is an empty space character, then we are using this condition at line number 8 and checking whether the previous character, the character previous to the space character, is equal to the character next to the space character, because the space character is the separator between two words. Okay, and the condition for a sentence to be circular is that the last character of a word is equal to the first character of the next word. So if this is we are able to check, then we are done. So we should not be using unnecessary overhead of splitting the string. So let's run this and check how it performs. Perfect. So see, our performance has increased manifold. Is this the only way that we can go about? Can we further improve our solution? I think there is this approach, and let me demonstrate that to you. Okay, and then I'll explain why this approach is better. Int k is equal to sentence dot index of space, and here we'll put if k is equal to -1, then there is no space, and then we can just return true, because we have already checked this previous condition and this is not correct. If it is correct, then we would have returned false, but sentence index of empty space character is not there, so that empty space character is not at all there in the sentence. It means that sentence only consists of a single word, and single word, this thing is not correct. It means we have not returned false, so it means this is true, and hence we are returning true. But if that k is not equal to 1, then what we will do, while k is not equal to -1, and then we will do one int we will check, we'll put a check, and what that check is, if sentence dot char@k -1 equals sentence dot char@k +1. Okay, then we will return. So if it is not equal, then we'll return false. Okay, but if it is equal, then we will allow it to go to the next step, and we'll update our index value. So how to update this? Sentence dot index of and then we'll use the our this character, and the last index was k, so we should go beyond that. So to go beyond that, we should do k +1, and so this will be updating the k, and that updated value will be checked at line number 8 whether it is equal to -1. So if it is equal to -1, then we are at the last word, and at the last word, after the last space character, when k becomes k goes beyond the index of the last space character, and again we are checking for the space character in the remaining sentence, then we get -1 and we'll come out of that loop. But as long as we are not coming out of the while loop, we'll be going inside the while loop and checking at the kth index whether the previous character of the kth index is equal to the next character of the kth index. If that is if that is true, then we will go ahead and remain in the loop. If that is false, then we'll quickly immediately return true. Okay, so this is the way this problem is going to be solved, and we'll run this. Perfect, and they'll submit this. So some mistake is there. How come if k is equal to -1, then we'll return true. My goodness, what have I written here? Perfect. So see, using index of has expedited our solution, and it is beating all other solutions. So why this benefit of using index of? The benefit of using index of is because had there been multiple characters, index of would have utilized some well established string pattern searching algorithm. But here, for a single character, this is using optimized loop, and also it is using the caches, the CPU caches effectively, because internally the index of is being written in a manner which is, the implementation of index of is using native Java code. So it's not Java itself, it's using native uh, language, and that language is expediting the uh, time complexity, the it's expediting the performance of this index of. Had we been using the linear scan in Java language, that would have taken longer, but this index of utilizes native code, and it also manages the loop very effectively, and it uses some optimization as well, and also it is uh, optimized for not having that cache misses, which is also another reason why this index of is performing better than manually going through the you know the strings character using a linear scan. So whenever we have to find out some particular character through the uh, string, okay, then index of is the best, or otherwise also, I mean to say, for longer character strings also we can use index of, and that is an optimized implementation. We should always go for optimized implementation to have better efficiency in our code. With this, I would like to